It's Mr. Benson here with my second video on the CAT solutions, going into level 8. So some things are a little bit harder, but again, if your bound reference is pretty well prepared, you should be in a good situation. So starting on the first question, just a perimeter question. Now, there's really nothing harder about this. They just kind of classify the different shapes as being at a slightly more challenging level. But all you had to do with this one was just to add up the side lengths. So we've just got that the perimeter is going to be 25 plus 11 plus 11 plus 35. And we ended up at, what was that, 82 centimeters. So that was relatively straightforward and fairly well done. Okay, so question 10 is a kite. Now, I didn't talk about kites in class specifically. If you actually read through the chapter, you probably would have come across it, or you might have encountered them before. Now, if you haven't done kites before, then you can actually work this one out, although it's a little bit tricky. Just that it is going to be a bunch of triangles, and you just have to kind of figure out the dimensions of triangles, and then you should be able to work out what the area is. Now, that's kind of a long way of doing it, but essentially what you're doing is just recognizing that the overall area of a kite is just half of the base multiplied by the height. Now, you might not entirely believe me there. Another way of showing you that is to go, okay, if we made a rectangle that was 39 meters tall, so I'm going to kind of try and sketch that rectangle here. So here's the base of the rectangle. So it's 39 meters tall, and it is sort of these the sides there, which are very wonky. And it's 39 meters tall and 25 meters wide. Now, if you think about that total area of the very wonky rectangle that I've drawn, the kite is half of it. So yeah, that's just the formula we need to use, half of the base times the height. So we just go half of 25 times 39, and we end up with 487.5. Now, meters squared is the correct unit for area. Okay, calculate the area of the circle shown below. Now, this one was meant to be pretty straightforward because it's just the area of a circle. One thing that did confuse people a little bit was whether or not this was actually going to the center. Now, generally speaking, people who write tests are not completely horrible, and they're not trying to just trick you to make you do stuff wrong. They're trying to make you think. So if it looks like it's going to the center, it's going to the center. But the main errors that people made with this is that you didn't recognize that this was the radius. So R was 22 millimeters. So people were doubling this, and they were halving it and doing all sorts of stuff that they didn't need to do. So the area of a circle is just pi r squared. So all you needed to do was put in your calculator pi times 22 squared, and you ended up with 1520, I'm just going to round it to 1521 millimeters squared. So yeah, this was definitely one where not recognizing what the radius was a big problem. Okay, converting units. Now, this one, again, a little bit tricky. You might have come across it if you look through the book. You may not have, but again, it is the kind of thing we can work out. So what we've got to think about is we can think about the definition of a litre, which is definitely something that I talked about before. So 1 litre is 1 decimeter cubed. Now, if we think about a cubic meter, so I'm going to sketch a dodgy cube here. Now, a decimeter is 1/10 of a meter. So what that means is 1 litre is like a little kind of cube, kind of chopped off the corner of our cubic meter there. But there's 10 decimeters in the height, there's 10 decimeters in the width, and there's 10 decimeters in, the depth of that larger cube. 10 times 10 times 10 is 1,000. So 1 cubic meter equals 1,000 litres. So all we had to do is multiply our volume by 1,000. So the overall volume of the swimming pool in litres is 125,000. Okay, now this is a more common one, but again, it might confuse people a little bit, but I definitely did go over the idea that 1 cubic centimetre is the same as 1 milliliter. Now, milli, the prefix, is saying that there is 1,000 mils in a litre, or 1 mil is 1,000th of a litre. So we're converting this to litres, so 3.1 centimetres cubed, or 3.1 mils in litres, so it's 3.1 divided by 1,000. So we're moving our decimal point, to 3 places to the left, so we get 0.0031 litres. What is the diameter of a lake that has a circumference of 2.49 kilometres? Now, this is relatively straightforward. So you've got to think about what we know. So we want to find the diameter, question mark. Now, I haven't specified the unit, so I'll just leave that in kilometres. But we know that the circumference is 2.49 kilometres. And so the relationship we're looking for here is that C is pi times d. Now you don't need to worry about the radius and stuff because you know this works with the diameter. So we want to find d, so d is going to be c over pi. That's just relatively straightforward algebra there. So I've just got to substitute my values in. 2.49 over pi, do it on your calculator to get the most accurate answer. 0.79 kilometers is okay. Now this one confuse people a bit. Now there was a bit of a typo in this which I apologize for, but one thing I'd like to remind you of is in pretty much every exam you ever do at school, right up until the final exams in year 12, in every other exam it is fine to ask questions. So if you are doing something and there is an error or it's unclear or you're not sure of the definition of a word, then you can always ask. We might not tell you, but we will, we'll help to clarify things, because I'm not setting out to, again, I don't want to see people lose marks just because you didn't understand a question. I want to test your actual understanding of maths. Okay, so what I was really looking for here, because we haven't said what x is, I just wanted to get an expression for the shape. So we've got to think about the stuff that we know. So we know that the top side is x plus 2 meters. The bottom side is x plus 8. Now we've got 5 meters here, but what we've got to think about as well is what the symbol means here. It means that we must have, whoops, I need to change my color there. We must have 5 meters on this side as well. So really all I was looking for was just the fact that P is going to be, so x plus 2 is one side, plus, now I'll put that in brackets, not that it will make any difference at the moment, plus x plus 8 plus 5 plus 5. So then when I simplify this, so I've got x plus x is 2x, and then I've got 2 plus 8 plus 5 plus 5 is 20. So I end up with 2x plus 20. So that was all I was looking for there. Just seeing that you understand the idea of perimeter, but that you can express it without always needing to use or to find an answer, but you can just, create an algebraic expression. Okay, now question 16. This was a bit of a beast, but it's not super difficult. There are parts of this that are really straightforward, but you've got to, again, think a little bit about what you're being told and think a bit about, the stuff that is hopefully in your bound reference that will help you with that. Now, stuff that we need to think about. It's a triangular prism, so this is the shape of the bar. Now, the first thing I'm going to do, not because it's necessarily the first thing I need to do, but it's just a calculation, is I'm going to work out the volume of the bar. Now, in exams and stuff, if you can do something with a question, like if there is something you can calculate, you probably should calculate it. So the volume of the bar, now it's a triangular prism, which means it's going to be the area of the end, so it's going to be a half of the base times the height, because it's a triangle, multiplied by the length of the bar. So what I've got to do there is I've got to put that, just put those values in and calculate the volume of each bar. It's a good place to start. So I'm going to do half of, so what is it, 5 wide times 5.4, and it's 30.6 long. And so what I end up with, each bar is 413.1 mils. All right. Now, if you did nothing else, I'd still be looking at that and going, cool, you understand what a triangular prism is and how to calculate the area of it. But, you know, one error that people made is that they just did the height times the width times the length, which would only work if it was a rectangle, not a triangle. Okay, so now what we've got to think about is, what is the maximum number of bars that can fit into a box? Now, I'm actually open to accepting a few different answers to this one, but I'll show you what I thought about it. So we know that the box is 32 by 32 by 32. Now, what that means is, to make things a little bit simpler, we can only fit one bar along one side. So what we're really thinking about is how we can pack them in kind of side by side with each other. So I did a bit of a dodgy sketch of the box. Now we're looking side on at the bars, and I know that the first bar at the bottom is going to be sitting something like that. Now, one thing I know is that these bars are 5.4 high. Now, I've got a total height of 32 on the box, so all I've got to really think about is how many times does 5.4 go into 32. Now, if I do 6 times 5.4, I'm actually at 32.4, so I can't have 6 layers. So the maximum I can have, now, okay, to be honest, you can probably squeeze in some more, but I just left it at this. I've got 5 layers, so 1, 2, 3, 4 and 5 at the top. So I've got 5 layers. So then I'm kind of going with, okay, so how many can I fit in a layer? Now I know that they're 5 wide. Now what that means is that, well, 32 is greater than 30, so I can fit 6 bars, 3, 4, 5, 6 across. So far I've got 5 layers of 6 bars, which would be 30 bars in a box. But there is a little bit of a trick here. If I've got these bars that I've already drawn like that, then I can actually fit other bars in on top upside down, like so. So I can fit 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 bars in each layer. So where I end up with this is I've got 5 times 11 equaling 55 bars. So that's what I reckon is the number of bars in the box. So then the question says, okay, so I've got how many you could fit in. Now, you could probably argue that you could maybe fit some bars up there and that you would have some more. To be honest, not many people got this far into it, but I would have accepted those sorts of answers. Okay, so volume of bars in total, so I'll go VBT, is going to be 413.1 mils multiplied by 55 bars, and what we get is 2272, I'm just going to go 720.5 is what I got, mils. So 22,700 mils, which is 22.7 litres. Where was it going with this one? Right, and then what it says is what's the empty space in the box? So the volume of the box is pretty easy to work out. All we've got to do is length times width times height. So we've got, you know, our 32, in this case it's just 32 times 32 times 32, 32 cubed, and that is 32768 mils. So, or cubic centimeters, whatever you want to call it. Now, then what I want to find is the empty box, and it's just going to be the difference between these two numbers. So V empty is just going to be 32768 minus 22720.5, and we end up with 10047.5 mil. Okay, now granted, that is a trickier question. You know, you've got to do more stuff in it, but none of the steps is actually that hard. You know, if you think about the steps that are involved in this one, we've got the calculation of the volume of a triangular prism. We've got the so we've got, which is, you know, this section here. That's a relatively easy thing to do. We've got the volume of a box, super easy. The problem solving part, okay, is a little bit tricky because you've got to visualize it and maybe do a diagram. But again, okay, look, I would have accepted a bunch of sensible answers.